Hello, everybody. Um, my name is Patrice Ngasa, and today we are going to talk about SmartAuth, which is basically a user-centered authorization for the Internet of Things. Um, I would like to acknowledge, this research was done by um, the authors that you see at the bottom there, Jan and others. They're the one who did all the work and all the user studies and everything. Um, I'm basically going over what they did and presenting that to you guys. Let's talk quickly about what we're gonna cover during this presentation. We first gonna discuss really quickly Internet of Things app and security, and specifically the Samsung SmartThings app. Um, that's one of the focus they have in their paper, and the fact that they also work with Samsung on this. Um, Next, we're gonna go discuss um, how the Samsung SmartThings app um, is overprivileged because um, they're using more permissions that they normally should. Um, and also next we will discuss about the Internet of Things app security challenges. Um, yeah, they all come with really uh, serious challenges for the implementation. So it's worth mentioning that. And next, we will discuss the implementation and the design overview of the SmartAuth app approach. Um, I think it's very important since we are discussing about the SmartAuth app here to show how they accomplish that to overcome those challenges. And next, we would also go through an evaluation of the SmartAuth app to see how come this SmartAuth app is actually addressing some of those issues or challenges. And we're gonna wrap up this presentation right after that and quickly have a discussion, maybe with some open questions. Yeah, so a few Internet of Things app that we you might know, um, the Samsung SmartThings app, obviously. I already mentioned that. We also have Google's Weave and Brillo. Um, and also another example is the Apple's HomeKit. You might be familiar with those. Um, Specifically, if we look at the Samsung SmartThings app, a recent study on that brought to light a security risk um, that largely really caused by inadequate protection under the framework. This is basically what this research paper actually focused on. Um, these are things that usually occurs when what the user actually reads in the app description of what the app is meant to do and what actually happens. Um, and obviously, things can go really wrong really quickly. Um, those, as you can see there, we have different devices in our home that can be impacted by that. Um, we have the thermostat there, the smoke alarm, or even locks that could, really be impacted by this. Internet of Things platform often requires users to grant permissions to third-party apps, such as the ability to control a lock or a light switch in your house. Um, Doing so involves, security challenges, and there are different security challenges with different devices, obviously. The SmartAuth app particularly uh, automatically collects security relevant information from an IoT app description, code and annotations, and generates an authorization user interface to bridge the gap between the functionality explained to the user and the operations the app actually performs. This is a key feature of the SmartAuth app that is lacking in apps such as the Samsung SmartThings app. This is an example of the Samsung SmartThings overprivileged permissions. You might see here how when we install an app on our smartphone, we perform actions that sends commands over the cloud, and the cloud therefore sends instructions that goes through the smart home hub that at the end of the the chain sends the command wirelessly to the smart lock, or it could be our smart TV or a smart fan. And we might see in the Smart Things app that the the app is actually just taking care of a lock, to opening or locking the door, but that app might have more permissions or be able to do more things that we think, which shows how the functionality explained to the user is not actually is actually different, I would say, to the operations that the app indeed perform or can perform. Let's talk really quickly about the IoT app security challenges that I mentioned earlier. Um, as a serious security risk, remote access can enable apps to send sensitive data to and receive commands from third party servers that directly impact your house through the Internet of Things devices. um, Security and privacy implications therefore depends on the context. An example would be the sensor in your bathroom versus a sensor outside the house. They're definitely different, and somebody uh, accessing those for malicious intent could could be really dangerous. Another challenge would be behaviors in code cannot be mapped directly to high level functionality in descriptions. Um, that's also something important. The need to support cross devices. That's really important since there are so many different type of Internet of Things devices on different platforms. Having a smart off or a smart app that can connect and communicate with all of them is definitely a challenge. and a great one. Now let's discuss the SmartAuth implementation goals to overcome those challenges. Um, the the SmartAuth app goes with the first of all the least privilege approach, where the system should grant only the minimum privilege to an IoT app, just enough to support the desired functionality. Um, the second point, the IoT specific, which means the authorization system for a smart home framework should meet the needs for multi device, context based, automatic operation compared to a single device for older smart home apps. The permission model here is based on the manifest permissions or at runtime prompts, such as those employed in Android and iOS. Um, Either do not allow user to make context-based decisions or cannot satisfy real-time demand. An example would be the approval to actuate an alarm when fire is detected. Um, Third, um, usability. I think usability is very important. The authorization system should be human centric, minimizing the burden on users while supporting effective authorization decisions. The authorization system should be lightweight and compatible with most existing systems out there. Now, let's talk about the smart of design. This is a high level block diagram of the smart of system. As you can see there, it has a program analyzer, a content inspector using neural language processing to inspect the app description, a consistency checker, a security policy, authorization creator, and a policy enforcer. Designing the smart of authorization system was done with the previous goal in mind. They are crucial to its implementation. Really quick, I mentioned security and privacy, Internet of Things specific, usability, performance, which are meant to be lightweight and compatible. In order to properly design the SmartAuth app, the researchers actually perform a few user studies and also some experiments. Um, as you noticed earlier, there are different parts to the SmartAuth designs, and the program analyzer among them, uh, which you see an example here, uh, was used to extract and app security critical behaviors. They perform a static analysis on the app source code and use natural language processing techniques on code annotations and API document. And they collected the source code for 180 Samsung SmartThings apps from an source level market in May 2016. This represents 100% of open source uh, app and 80.2% of all smart apps at that time. This is an example of the app description analysis using the natural language processing for the coffee after shower description. Um, Natural language processing analysis for this app is designed simply to turn on your coffee machine while you are taking a shower. Here, the red and blue characters respectively indicate part of speech. This is an illustration of three-step policy correlations for a coffee after shower app. They applied the context clue bathroom and coffee for entity correlation. They used the attribute model and command model to extract and correlate the context and action. They also use type dependency analysis and causal relationship model to correlate the policies generated from the description and program analysis. Um, if you recall, in the design, we also had an authorization interface generation. Um, as you can see there are three main part to this interface generation, matching users mental model, which should put less burden for the user and alarm users about unexpected behavior. This is very important. Um, a survey users' perspectives of installing smart home app, and finally, iterative design with pilot studies. Um, these user studies were done to understand better the what users think, and obviously to build a mental model that will work for almost everybody. Um, Also, the policy enforcement was part of the design. Um, Here you can see a little bit how uh, commands are deployed over the cloud, and how they go and reach the IoT devices. User install IoT apps through mobile devices, allowing the vendors IoT clouds to interact with the user's locally deployed devices. IoT apps pair event handler to devices, issues direct commands, and enable external interactions via the web to actually communicate with them. Now let's do the SmartAuth evaluation to see if they actually address the challenges that we mentioned earlier. Um, and obviously, answering this question would help us understand that those the SmartAuth actually meets the implementation goal stated earlier. um, Effectiveness, policy extraction accuracy, the user's decisions impact by SmartAuth, the performance overhead is were there any, and also the compatibility issue. The SmartAuth actually meets all those implementation goals. How effective was the SmartAuth app in extracting policies? Evaluating the SmartAuth app's ability to accurately identify unexpected behaviors is very important. To this end, they manually analyze the description and the code of 180 available SmartAuth app and compare the result to those of the automatic analysis. In this process, they did not observe any false positive, though they identified 7 false positive, which is the equivalent of 3.9%, in which SmartAuth flagged a behavior as unexpected, though manual analysis of these cases had suggested otherwise. These are the impacts on users. For five tasks, participants who chose between two similar Internet of Things apps, one of which was overprivileged. This graph shows the proportion of participants who chose the overprivileged app, similar to what one would expect from random selection. Around half of participants who saw the Samsung SmartThings interface chose the overprivileged app. In contrast, only between 6% and 26% of SmartAuth participants chose the overprivileged app. This simply means that user may, made better decisions with the SmartAuth app. Now, let's look at the performance and compatibility. As you can see there on the chart, they plotted the average delay of various functions in the SmartThings platform. The darkened bar in each pair represents the delay in the unmodified platform with virtual devices, while the lighter represents the delay in the customized platform with the additional overhead introduced by SmartAuth. Event Handler incurred the highest incremental overhead, while commands incurred the highest proportional overhead, almost double the base case. Even after they are patched to remove the overprivilege, the 180 apps behave the same as the original version, which is great. In other words, patching does not break the functionalities claimed in the app description. Observe behaviors and debug information. None of the app crash. In the extreme case, 3.3% of app loss functionality when they blocked all the remote access. In a 100 participant laboratory study, they found that the SmartAuth helped users better understand the implicit policies within apps, effectively identify security risk, and make well-informed decisions regarding overprivilege. For instance, given two similar apps, one of which was overprivileged, using the current Samsung SmartThings interface, 48% of participants chose to install the overprivileged app in each of the five tasks. With the SmartAuth, however, this rate reduced to 16%, demonstrating the value of the SmartAuth in avoiding overprivileged apps. In conclusion, we can say that the goal was achieved, bridging the semantic gaps between what a user sees, which are the app descriptions, and what the app code actually does. This is very important. Also, the users were much more likely to choose safer apps with SmartAuth. That's very important. Now, now let's get into a quick discussion. Myself, as a Samsung SmartThings user, how do I feel after reading this research paper and all the findings? Yeah, I was definitely glad to know at the end. It was more of a relief to learn that these researchers were working with Samsung to actually deploy a patch in the Samsung SmartThings app. That was definitely great to hear. We could ask ourselves now, should we trust Internet of Things app? Um, that's a very difficult question to answer because it really depends, on multiple factors, such as who actually build the apps. You could look different informations about that and have mixed feelings about which app to install, or who are the builders or the architect, or how was it built. Different questions could cross your mind now that you learn about all these things. And without a doubt, context and privacy do matter when it comes to Internet of Things devices in our house. The fact that there's a sensor in the bathroom and a sensor, in the kitchen, they are both sensors, but because of the way they are, context matters. They could really be treated, they should be treated differently for sure. Going beyond this class, I have an open question that I wanted to address to my audience. Could this strategy or this type of analysis be part of a validation system used to filter well-designed applications because before they are approved or available to users for download in the App Store? This is something important that I think Apple or Google should think about and maybe leverage that. Thank you.